Hi dear students and viewers, welcome back to our channel Anvane Kumar Basics of Physics. Dear students, in this channel you are going to learn about the first year physics, secondary physics and along with MSET, NEET and 9th to 10th class physical science also. Videos are available on our channel. That's why if you can subscribe my channel and share and like my channel. So coming to the point, dear students, in this video you are going to learn about one of the most important topic, that is in the chapter of mechanical properties of fluids. So this is important for 8 marks question. Based on that, so many applications are there. They will come in the exams like 4 marks questions. That's why that much of important topic we are going to discuss in this one. The topic is Bernoullis theorem and its proof. So this is the mechanical properties of fluid chapter, and in that this is one of the most important long answer question. Clear? So without late, we will go to the topic. Children, if you can watch the video up to last, then only my content will reach you. Otherwise, so if you want to learn subject, you have to wait. That's why watch the video up to last. Okay, coming to the point. Dear students, what is meant by Bernoullis theorem? When a streamline flow of an ideal fluid is passing through any pipe, then its sum of pressure energy, kinetic energy and potential energy is same. This is what we call Bernoullis theorem. When a streamlined fluid flow of an ideal fluid that should be passing through any pipe, then its path, sum of potential energy, pressure energy and kinetic energies remains constant. So the same statement is available on the board. Look here. So the equation is given by the formula P plus rho H plus of rho V square is equals to constant. This is also written as P1 plus rho 1 GH1 plus of rho 1 V1 square is equals to P2 plus rho 2 GH2 plus of rho 2 V2 square. So we can write Bernoulli statement this also, like this also. Okay, this is the one form and this is the another form. P plus rho H plus of rho V square equals to constant. Children, look at this statement. In the statement, one word it is there. For the streamline flow of this is the first thing, streamline flow of an ideal liquid the sum of the pressure energy, potential energy and kinetic energy per unit volume is always constant. This is what we call Bernoullis theorem. Now we have to prove this one, children. So in this one there are two words are there. What the first word is streamline. What is mean by streamline flow and what is mean by ideal liquid? Dear students, for example, it is the fluid. In that fluid at particular height we are selected some points like this. Clear? At the same here we are taking some points which are at the same height. At the heights the velocities of the fluid is same. Then if you can join the one line, that should be called a streamline. The locus of or the line joining of the points in a fluid at which points the velocity remains constant, that particular line is called streamline. Clear? Streamline flow means in that different points which are at the same height, they have same velocity of fluid. That's why here the first thing is what? So the streamline flow should be shown like this. Clear? So per particular line, on that particular line at every point velocity is same. At every point on the same line should be here what we call velocity is same. Here velocity is same, here velocity is same, here velocity is same. Now it is called a streamline. Clear? And now this is the another streamline. This is the another streamline. On that streamline, some points are there. Those points are also having the same velocity. Clear? So now here that particular flow, what we call streamline flow. That is the first thing. And next thing is ideal liquid. When a fluid is said to be ideal, for that one here, one definition is there for an ideal fluid. So children, no need to write examination about the what is mean by ideal fluid, but we have to know. So ideal fluid means if a fluid is like non-viscous fluid, non-viscous, the first thing is, and second one is incompressible fluid, incompressible fluid, and third one is irrotational. What is irrotational? And fourth one is streamline flow, streamline flow. So if any fluid consists of these properties, then that fluid is said to be ideal fluid. What it is? Ideal fluid. So just now only we discussed about the what is streamline flow. And now here, what about the non-viscous? So dear students, so all of you know what is frictional force? A tangential force acting between the two bodies which are in contact, that should be what we call frictional force. If any two bodies are in contact, in between them there is tangential force is acting between them, that is what we call frictional force. In the same manner, in a fluid, if you can imagine the fluid into the number of layers, then the frictional force acting between the layers of a fluid is called viscous force. Clear? What it is? There is some tangential force acting between the two layers of a fluid. That should be what we call frictional force. It is also known as viscous force. Clear? So if there is any frictional force between the two layers of the fluid which are in contact, then that fluid is said to be viscous fluid. If there is no frictional force between the two layers of a liquid or fluid, then that is what we call non-viscous fluid. So what is non-viscous fluid? There is no frictional force, between the fluids which are in contact. So to understand that, I am drawing here. This is the one layer of the fluid, and this is the another layer, and this is the another layer, and this is the another layer. So I am saying now it is the first layer, and this is now second layer. The direction of moving of fluid is like this. Then this one is moving in this direction, second also moving in the same direction. But here there is some tangential force acting between those in opposite direction like this. So this is the viscous force or frictional force between the two layers. The fluid is moving in one direction and viscous force is moving in opposite direction. So if viscous force is there, that fluid is what we call viscous fluid. If frictional force is not there, then it is what we call non-viscous fluid. So to say that ideal liquid, first property is what? Streamline flow, and second one is what? Non-viscous fluid. And second thing is what? Incompressible fluid. Incompressible means you can take any two portions of the fluid, then the density is same at the two portions in that fluid. Clear? You can take two different positions in a fluid, then the density must be first where it is there, that should be same as at the second position. That means there is no change in density of the fluid. Then that fluid is what I have to say? Incompressible fluid. Clear? That means here simply we are taking rho 1 is equals to rho 2 is equals to rho 1 minus rho d is 0. That means there is no change in density. Here what is rho 1? Density at the first position. And what is rho 2? Density at the second position. Clear, children? So, and now third one, irrotational. if the fluid should be like a steady flow. Sometimes we will find some circulating places are there in fluid. Generally what we call eddies. When eddies are formed, automatically there is some angular velocity is there. Then that fluid is called rotational fluid. Clear? So in Telugu what we say, Suriyundal is something like that. So when the fluid is in motion, at some positions we can find that the water should be like circulating like eddies. Clear? If it is like that, that means that there is some angular velocity is there. Angular velocity is there. Angular velocity is there means what? The water is in circular motion at some positions. Then the type of fluid is called rotational fluid. Rotational fluid. But in this case, we are taking the irrotational fluid. That means there is no angular velocity. There is no change in angular velocity. There is no angular velocity. There is no angular velocity, zero. Clear? And now the fourth one is what? Streamlined flow means what? Velocity is same. So if any fluid consists of these properties, then what I have to say? That is the ideal fluid, children. So now we can go for the proof of the Bernoulli's theorem. Proof of the Bernoulli's theorem. For that, there is one diagram on board. It is there. Children, watch very carefully here. So this is the one pipe. What it is? This is the one pipe, and first end of the pipe is here at the height of h1 from the ground, and second end of the pipe is at the height of h2 from the ground. Clear, children? So the fluid is entered at the first end, that should be moves like this. Clear? So what I am saying is the streamlined flow, children. So you can take particular area. You can take particular area here. So at the first end, the area of the pipe should be here. We are taking A1. What is A1? Area of cross section. Area of cross section. And P1. What is P1? Pressure. What is pressure? So this is the pressure of the fluid. Okay. And now what is V1? Capital V1 is the volume of the fluid. Volume of the fluid. And small v1 is the velocity. What is it, children? Velocity. So if you can understand this only, the diagram is going to be very simple. And now delta t is what? Time of moving of fluid. And now here, and finally what I am going to say, that is delta m1. What is delta m1? So delta m1 is what? Mass flux or mass enter into the pipe. Mass enter into the pipe. So these are the at the first end. What is A1? Area of cross section. What is P1? Pressure. And V1 is what? Volume of the water entered. And V1 is what? Velocity of the fluid. And delta T is what? Time. Delta M1 is what? Mass of the fluid that should be entered. Same thing here, also same thing. Delta M2 is the amount of fluid or amount of mass of the fluid is leaving. And P2 is what? Pressure acting on the exit fluid. A2 is what? Area. V2 is what? Capital V2? Volume. V2 means small v2 means what? Velocity. And delta T is same thing, time. So in this case, you have to take, children, only the fluid which is entered, that is going to be leave. That's why here rho 1 is equals to rho 2 is equals to rho. You have to remember that the fluid is which is enter into the pipe. At this portion, what I am saying here, rho 1 is density of the fluid. Rho 1 is what? Rho 1 is the density of the fluid. Density of the fluid. And the same fluid is leaving. That's why here rho 2 is there, density there. That's why what I am going to take. Rho 1 is equals to rho 2 is equals to rho. At the same time, here the amount of mass that is going to be entered, that should be equals to the amount of mass leaving. Clear? And here again delta T1 is equals to delta 2. That means in what time that is going to be entered, same amount of water should be for leaving the pipe from second end, that will take the same time. So to derive the Bernoullis equation, you have to remember these things. What is P1 A1, V1 R1, and P2 A2, rho 2 V2, D2 like that. So you have to know the about the particular letters, and the condition is what? Rho 1 is equals to rho 2 is equals to rho, and P is equals to rho. This is what rho. Delta M1 is equals to delta M2. Delta D1 is what? Delta 2. So by using them, we have to derive the equation now. Let's go for that. Now we have to go for how we can prove the Bernoulli's theorem. So dear students, so as usual what we discussed, P1 is the pressure and P2 is the pressure at the second end. This is the area of cross section of first one A1, and this is the area of cross section of second end A2. So already we discussed just now only. So in this case, the work done by the pressure on liquid, first thing is what? Work done by the pressure at the first end. So what we know, children, W is equals to what, right? F into S we can write. This is the general formula. Work is equals to force into displacement. So dear students, what we know, P is equals to F by A. P is equals to F by A. From that, force means what, right? F is equals to P into A we can write. So therefore, W is equals to P into A into displacement is delta X we are saying now. First, for the first end, that's what I will write. This is the P1 A1 dx1. So children, what we know, velocity is equals to displacement by time. Velocity is equals to displacement by time. We are writing V is equals to delta X by T. From that what, right? Delta X is equals to V into T we can write. Clear? So velocity is equals to displacement by time we can write. That's why what we write here, instead of delta X, what we write? Velocity into time. So already we discussed what it is. Velocity here V1 and time is delta T. That's why here W is equals to P1 A1 dx was what? V1 delta T1. Clear? So P1 A1 V1 delta T1 is the work done by the pressure on fluid. Pressure on fluid. Or it is on fluid. So similarly, now the work done here, work done by the fluid, because of pressure. Same formula we will get at the second end. W2 is equals to P2 A2 V2 delta T. Again, if you understood this one, the same we will get the W2 is equals to P2 A2 V2 delta T. Here, this is the work done on the fluid. Now this is the work done by the fluid. Because of pressure P2. So that's why here the net work done should be given by W is equals to W1 minus W2. Here W1 is greater than W2 because P1 is greater than P2 here. Clear? That's why plotted simply here now. W is equals to W1 minus W2. So there we have to write W1 means what? P1 A1 V1 delta T minus P2 A2 V2 delta T. So children, here I am writing here, this is the area into velocity into time. For that I am going to write unit. Area means what? Meter square. Velocity means what? Meter per second. And time is what? Second. Second cancel. Then what you get? Meter square into meter cube. So simply here area into velocity into time. So here dt1 delta t1 is there, delta t2 is there. So already I told you starting of the video, delta t1 delta 2 both are same. That's why I am going to write delta t. Clear? So that's why here area velocity time. That's why I write W is equals to P1 delta V1 minus P2 delta V2. Clear? So simply here is the equation number 1. Got it, children? This is the work done by the pressure. So due to that, some change in potential energy takes place. Due to the work done, change in potential energy will take place. So children, what is the equation for potential energy? mgh. So from this figure, what you have to say? H2 is greater than H1. That's why here for the second end the potential energy is maximum, and for this one minimum. That's why due to the amount of work done, there is some change in potential energy. That should give me the m delta m2 g h2 minus delta m1 g h1. Potential formula is what? Mass into acceleration into gravity into height. Here mass, what did I told you? Delta m1 is entered and delta m2 is leaving. That's why here what to write? Delta m2 g2 minus delta m1 g h1. Clear? So after that, children, there is some other formula. It is there. What it is? Rho is equals to what, right? Mass per volume. Density is what? Mass per volume. From that, what, right? Mass is equals to rho into V can write. Mass is equals to rho into V. So here mass nothing but here delta m. Delta m is equals to density into here volume. Density into volume. That's why here instead of delta m2 I am going to write delta m2. I am going to write rho 2 s V2. Delta m1 is what? Rho 1 V1. Clear? So here again V1 is the volume at the first end, V2 is the volume at the second end. So that's why here simply we are going to write delta U is equals to rho 2 into delta V2 into GH2 minus rho 1 into delta V1 into GH1. Here you will take V1 is equals to delta V1 and V2 is equals to delta V2. V2 is equals to what? Delta V2. So simply you can take small area of cross section, that's why volume should be taken as delta V1, and for the small volume what you write? Delta V2 this is. Okay. That's why here we simply write delta E is equals to rho 2 delta V2 GH2 minus rho 1 delta V1 GH1. Clear? So this is the equation number 2. So this is what about change in potential energy. Change in potential energy. So children, I need some space, that's why I am erasing this one. In the same manner, there is some change in kinetic energy takes place. There is some change in kinetic energy should be also takes place. So that's why here we will write. So due to the work done, some change in potential energy takes place, some change in kinetic energy also takes place. That's why here delta K is equals to here half m v2 square minus half m v1 square. m1 v1 square. Okay, this is the m2 v2 square minus half m1 v1 square. So in this case also what you have to go and take here, v2 is greater than v1. That's why the kinetic energy is more here and it is less here. Clear? So that's why here we are going to write delta K is equals to half into just mass what I write? Density into volume. That's why here I am going to write rho 2 into delta V2 into V2 square minus half into rho 1 into delta V1 into V1 square. Here V1 is the volume, V2 is the volume. Here V2 is velocity, here V1 is velocity. So how we got this one? Rho is equals to mass per volume, and volume is equals to what? Mass is equals to what? Rho into volume, like that. That's why here from that one we are writing simply here delta K is equals to half rho 2 delta V2 square minus half rho 1 delta V1 square. So in that formula, children, we are going to take here rho 1 is equals to rho 2 and delta V1 is equals to delta V2 and delta M1 is equals to delta M2. As per conditions what I told you, it is having same density. It is the incompressible fluid. That's why here mass is same, volume is same, and density also same. Density, volume, and mass also same according to the definition of ideal fluid. It is the ideal fluid. That's why there is no change in density, and the amount of flux also same. How much mass is entered? That the same amount of water should be same to be leave. Okay. That's why it is the ideal fluid. Simply you have to remember for the ideal fluid you will write rho 1 is equals to delta V1 is delta V2, delta M1 is delta M2. So According to that one, I am going to write delta K is equals to, I am going to write here half into rho into delta V into V2 square minus half into rho into delta V into V1 square. Clear? So simply what write delta K is equals to half into rho into delta V means what? V2 square minus V1 square. This is equation number now 3. Clear? So according to the work energy theorem, according to the work energy theorem, or you can say anything according to the law of conservation of energy, what you have to write, delta double is equals to delta K plus delta U. Clear? That is the, you have to solve the values here now. What is W value? P1 delta V1 minus P2 delta V2. So W is what? P1 delta V1 minus P2 delta V2 is equals to. So children, I need some space, that's why I am erasing this one. If you want to write prepare the notes, just pause the video and after that you can write that one. So here I need some space because we have to substitute 3 equations in the formula. So that's why I need some space, that's why I am erasing all these things. So look here now. W is what here write? I am going to W is equals to delta K plus delta U. Formula you have to substitute. What is W1? W what it is? P1 delta V1 minus P2 delta V2 is equals to, second equation what? Yes, this one. Rho 2 delta V2 GH2 minus rho 1 delta V1 GH1 plus, this is the equation. What do you know? Of rho into delta V into V2 square minus V1 square. Clear? So in this formula, what I already told you what it is? Delta V1 is equals to delta V2, rho 1 is equals to rho 2, and yes, like that. Delta M1 is equal to delta M2 also. So here what write? P1 delta V minus P2 delta V is equals to, rho 2 is what? Rho 1 or anything, whatever may be rho. Okay. Rho delta V GH2 minus rho delta V GH1 plus half rho into delta V of V2 square minus V1 square. So here children, among both sides you have to take delta V is the common. Delta V is the common. That's why here we are dividing on both sides. So P1 minus P2 delta V is equals to rho GH2 minus rho GH1 of delta V plus half rho delta V V2 square minus V1 square by, we are dividing on both sides delta V. Clear? So delta V cancels. Then what do we get? P1 minus P2 is equals to rho GH2 minus rho GH1 plus, these are cancelled, half into, these are cancelled, rho into V2 square minus V1 square. So here, what were children? P1 minus P2 is equals to, this is 2 we have, so you can write rho 2 GH2 minus, this is rho 1 GH1 plus, multiply this one, half into rho into V2 square, rho 2 V2 square minus half rho 1 V1 square. So what we know, if you can multiply, what you get? Rho into V2 square will get, again rho into V1 square will get. So already what you know, rho 1 is equals to rho 2 is equals to rho. So that's why we can write like that. Now you can bring all the one terms one side and all the second terms one side. So P1 it is there, you can bring this one this side. Then what you get? Rho 1 GH1. Again this is what? Minus of rho 1 V1 square. Then what you get? Of rho 1 V1 square is equals to, Here you can take that side. Minus P2 is that is now plus P2. Already rho 2 GH2 is there. That's why I write rho 2 GH2. Again already we have of rho 2 V2 square. So this is the verification of Bernoulli's theorem. Here P1 is nothing but what it is, children? Potential energy, and rho GH is what it is? Potential energy. And now this is what? Kinetic energy. So here what we know? Simply 1 means what? That will represent the at the first end. 2 means what we get at the second end. That's why here this equation is represents the total energy at the first position, and at the second position this is 1. Clear? So sum of the pressure energy, potential energy, kinetic energies, where at the first end. At the first end, sum of pressure energy, potential energy and kinetic energy is same as sum of the potential energy, pressure energy, potential energy and kinetic energy. So that's why here this is nothing but what, children? We will write P plus rho GH plus of rho V square is equals to constant. So this is what we call, children, Bernoulli's theorem. Bernoulli's theorem, most important one. So dear students, if you want to prepare the notes, just pause the notes and pause the video and prepare the notes. Dear students, if you can understand this one, like, share, comment the video. So if you want to get more videos from my channel, just subscribe and support my channel. Thank you for watching.